Hi everyone, we're finishing up lesson 24 on point estimates of parameters. I almost forgot example 3 on sample proportions and probabilities, our coins example. So let's say you're given a magician's coin and you don't know if it's fair or not. So how would you estimate the probability that this coin comes up heads? Let's say heads is your favorite side. It represents a coin being a success. It comes up heads. You like faces. So you take this coin and you flip it 1,000 times. It comes up heads 510 times out of the 1,000. So out of the 1,000 times, that's n, the number of trials, you get x successes, 510. That's the number of heads because you're counting heads. Those are successes. Part A, find p hat, the sample proportion of heads among the 1,000 coin flips. And then part B, what is a point estimate for the probability that the coin comes up heads on one flip? Well, I hope you see that our value for p hat will be our point estimate for p. P is the probability that the coin comes up heads. Okay, p is the probability the coin comes up heads. Again, it's a magician's coin. It's not necessarily fair. Or at the very least, we don't assume that the coin is fair. Actually, in real life, many coins, in fact, you could say all coins, are not perfectly fair. So what's our best guess as to the actual proportion, or it's a probability this time, the probability that the coin comes up heads? The idea that if you flip the coin infinitely many times, what's the proportion of times it would come up heads? All right, so the solution. P hat, the sample proportion of heads, would be x over n. The number of successes, the number of heads was 510, over the number of trials, 1,000. That's 0.51. So you've got 51% heads among the 1,000 coin flips. And that would be our best point estimate for P, the actual probability the coin comes up heads on a flip. Again, 0.51. P hat is our best point estimate for P. This sample proportion of heads is our best point estimate for the actual probability the coin comes up heads, which again can be thought of as the proportion of times or flips the coin comes up heads on infinitely many flips. So we can frame P and P hat problems in terms of sample proportions or probabilities. In either case, we take as P hat our sample proportion, the number of successes in our experiment over the number of trials, or the sample size in our experiment. Next up, as promised, we're going to talk about issues of error, sampling error, margins of error. If you get 51% heads, does that mean that the coin couldn't be fair? Or is this just due to sampling error? We'll ask those kinds of questions next time.